Good morning. Good morning, everybody. We're super excited to be here today. So glad that you could join us. Today is September the 10th. It is 10 a.m. Central, and we have, albeit one of the best looking crews that we've ever had on these podcasts before. We're super, super excited. So my name is Monique Roberts. I'm the executive director of PODS. We are going to go through just a couple of housekeeping items, and we're going to go real quick because we just have a wealth of information that we're going to be sharing with all of y'all today. So Brad, if we can go to the first slide here. I'm going to give us a quick safety moment on Halloween. Can you believe it? I mean, fall is here. Oh, I jinxed it. Now the weather's going to go back to being hot in Houston again. I just jinxed it. So we are in the F word right now, which we will not say. So we're getting our pumpkin spice lattes and we're picking out what we're going to be for Halloween this year. So one of the things that we can do to stay safe on Halloween, which I think you parents will really like a lot, is to make sure you test that candy before you let your kids eat it, right? You just have to do, I guess, like a good selection set of it, what my dad would call the dad tax, right? And just make sure that all that candy's safe for them to be able to eat. Not because you want to eat the candy, you're sacrificing for your children. So just make sure we're staying safe on Halloween. We're keeping all of our colors bright so that we can be seen in the road. And we have a good and safe Halloween here. Okay, so with that being said, we're going to get through a few things real quick, really, really fast. Today, we're going to be talking about the PODS 7 model, providing an ideal system of record to support pipeline risk modeling, including qualitative, semi-quantitative, quantitative probabilistic algorithms. I don't even know how to spell any of that stuff. So, but we have the right people on board today that know all about it. So the podcast will review methods for managing key source asset and inspection data in PODS, using the use of PODS views to manage pre-processed risk factors, geoprocessing, and publishing of risk model results to PODS. So today we're brought to us by Geonamic. So we're super excited to have Geonamic, who's one of our gold sponsors here at PODS and just an absolute critical piece of our PODS community. And they're sponsoring this PODScast today, and they brought on their special guests as well. So we'll get into that. All right, so let's go ahead and go to the next slide. And now, while I have everybody on board, we want to go ahead and launch our first poll, and we want to see who's on our podcast today. So we want to know who you are, because the crew here is going to really try to make sure that they touch on things that are more specific to your role, right? We are definitely an organization here that we're very inclusive, right? We want these podcasts to be very interactive with each other. So because you're about to learn more about who they are, we want to learn a little bit about you. So go ahead and open that poll and give us a response. Now, look, we all know that we all have 50 jobs, right? Or 3 jobs, but only 1 paycheck, right? So go ahead and pick which thing is appropriate to you in your main role that you run. And then while you're doing that and running through that poll, I'm going to ask Brad to go to the next slide and tell us a little bit about the crew that we got today.
Great. Thank you, Monique. Good morning, everybody. Very happy to be here and got lots of hopefully exciting things to show you. I'm Brad Schaff with Geonamic. I'm a principal with the company, been involved in implementing tools for pipeline risk and integrity for over 30 years now. Joined by my business partner, Wong. He also leads our risk software and services here at Geonamic. And very happy to be joined by 2 of our business partners. Mike Levin from PipelineRisk. Many of you know Mike. He's been around also for about 30 years in the industry. And Rita Emmerich from GCR Integrity. We work with both of these, have many mutual clients, and are excited to continue to work with both and to let you see what they have to say. So just a quick introduction to Geonamic. I've been around almost 20 years. 20-year anniversary will be next year. Offices in Houston and Atlanta. Long and I are based here in Atlanta. We have quite a few staff in Houston as well. Completely focused on your industry, U.S. and globally. Working with 40 operators now and about 1,000 users using our software. We provide software and services, and recently we have been doing a lot of platform upgrades. I think we've either completed or have in progress more than 10 at the current time. And many times that's moving almost all of them to PODS 7, along with an upgrade of the Esri platform. And risk is almost always a part of that, or a driver. So as part of that, we've had the opportunity to help companies modernize their risk approach, working with PipelineRisk and working with GCR Integrity in particular. And we're a proud sponsor of PODS. So we volunteer with PODS, we're members, and we've also continued our gold sponsorship now for next year. So looking forward to that. So
Thank you
I'll
so
throw it
much,
back
Brad.
thanks for attending. Throw it back to Monique for a little PODS overview, and then we'll dive into risk.
Awesome. So yeah, I just want to say thanks again to you, Brad, and Wong as well, because you guys do so much above and beyond besides give us money, right? Which I appreciate. Don't ever stop doing that. But you guys have members on every single committee. You won the Service Company of the Year. You've won the Volunteer of the Year. You guys just do so much for us. So Wong, I know that you are super excited to talk about PODS. It's one of your favorite things to do. So do you have any questions in particular that you want me to cover with PODS?
No, yeah, thanks, Monique. This is great. Super excited about this. Yeah, I mean, this is we have a fantastic panel here. Of course, I'm Wong, and we're going to be talking about the trio of PODS, artificial intelligence and machine learning, and also Geonamic pipeline office studio risk monitor, stuff like that. Yeah, let's just start from the top here, Monique. I must start from here because for folks who are not really deep into GIS or pipeline, PODS sounds like a very technical term. So can you break it down? So what is a PODS? So for our audience to have a little educational experience.
Yeah, for sure. So this is my favorite thing to talk about besides myself, right? Is PODS is two different things, right? PODS is a community and it's a data model. And so when I'm meeting new people, and we get so many, like this year we've gotten 5 new operator members so far this year that have never been on PODS and don't know anything about it. So when I'm explaining what PODS is as a data model, it's just like the moving company, right? Which I get calls like once a week about, hey, come pick up this container out of my yard, or hey, you rented up my yard, right? And so it's kind of just like that. If you've ever used the containers for moving before, they bring it to your house, and believe it or not, when you get in there, there's a special spot for your couch, there's a special spot for your TV because it's padded and so it won't break, and your mirrors and everything else. Same thing with PODS, right? It's a structure with which your ILI data knows where to go, your CP data knows where to go. It's a great way to organize all of your data. It's actually used by PHMSA as well. PHMSA uses it as a baseline. So it's wonderful for your business, your risk, and your compliance tools, right? So for your decision making as well. So it is an open Esri compatible platform. We have some great things going on with Esri. Esri is our principal partner, and they're helping us out with all kinds of stuff. For instance, they're reworking our modules to be able to work onto UPDM. So now we're opening up the PODS platform to more people, right? Now, why is PODS special as a data model? And that's because of the community, right? The community are all experts in database architecture, in linear referencing. They're specialists in data management. They're specialists in risk. They're just like this motley crew that we have today, right? They come from a lot of different backgrounds. They work together to ensure that the model is standardized, that there's good data governance, and then that also that it's going to be compliant for all of our operators. We all know that asset knowledge is essential to confident compliance. We all know that the more and more visibility that we have to data, the more and more our pipelines are going to be operated safely. So we are a data model, but we're also a community of people that come together to try to move the ball forward in pipeline safety related to visibility of data, data governance, data management as well.
Sounds great. That sounds like a game changer. Yeah, let me do this first. Let me introduce our all-star panel. Mike Lovin, pipeline risk experts with over 30 years experience in the field. Mike, thanks for joining us today.
Hey, you bet. Thank you, Wong, and thanks everybody for joining us today. I guess what I'd say is, we've been applying AI machine learning for many years now, probably across more than 150,000 miles of pipe. And a lot of it is in the context of pods and advanced risk. So today, what I'm hoping to share with you is really just kind of our experience and kind of do's and don'ts and things we've learned, over the years. So just looking forward to interacting with everybody.
Thanks, Mike. And next, we are also honored to have Rita Emmerich, a pipeline integrity consultant with over 20 years experience and expertise. Rita has a tremendous experience working with a different flavor of pods, from pods 4 additional to latest pods 7. Rita, thanks for being here today.
Hello, Wang. Hello, everyone. I'm very honored as well to be a part of this panel and to join this discussion. And thank you, PODS, and thank you, Geonamic, for inviting me. And it's a very exciting topic for sure, and it's a game changer for big operators, but small operators as well. If when you have your data organized and not in a binder stored in one of those PODS containers that you were mentioning, Monique, but in an actual database, your data becomes transportable too, right? How you can move your PODS container from one state to another when your data is in PODS and it's compliant with what the rest of the industry is doing. It's easier to move when you sell assets, when you move assets, when you switch softwares. All those connections get maintained. So very excited to be here and looking forward to some of these discussions.
Yeah, that's great.
And
Rita,
did you see who's on the call? Did you guys see on the call? We have the majority of GIS and PODS data managers. So I think we're going to be really excited to talk to them specifically. But one thing I want to point out is that we have technical SMEs and leadership on the call as well. So one of the things that we need to really keep in mind is that, all of the awesome nerd things that y'all do, that needs to be translated right to leadership as well, so that we can support them and get them the information they need. So pretty cool that we have a wide array of people on here. Say, Wang?
that's great. That's great to hear. So Rita, thanks, Monique. Rita, I'll go back with you. Like I said, you're a PODS super user, and Monique said PODS is more like a super organized library, and then geomapping tools and AI, everything can be ready for that. Can you set a stage for an advanced risk modeler? How PODS can help the whole thing moving forward.
Yes, so thanks for calling me out as a super user. And out of these 20 years of, give or take a few more years of experience in involving myself in this pipeline industry, I think over 10 years, it's been also mutual relationship with the Geonamic and working on our mutual clients, helping them improve their risk management programs. So no matter what model you use, whether you're starting with a simple risk index-based index model or you're moving to probabilistic machine learning environment, it always starts with the data, right? So everybody would agree that people say garbage in, garbage out. So you don't have good data, you're not going to get good results. So adopting a standard like PODS and populating that data model and carefully choosing your domains and organizing your data in logical and structured manner, that helps you down the road, no matter what tool you choose for your risk analysis. So obviously, they use the simplistic models. We all know risk is, likelihood time consequence. So you can start very simple and just pick few factors, assign the rating from 0 to 10, multiply it by some sort of weight, and add them all up together. And here you have it. You have risk, but I think I'll touch on some of these advancements in that mentality here quickly. But at the end of the day, if you have a populated PODS, if you have a mature database, that's any risk engineer's dream come true, right? You have a good starting point with PODS. So if you have outdated PODS that doesn't support new tools and cool technologies like what Geonamic has to offer, then you need to join PODS, and then you need to migrate your databases to PODS 7. And I've been involved in several of those migration projects, and at the end of the day, clients are very happy because it opens up a world of options for them.
That's great to hear. And Mike, I'll go back to you. Risk assessment is a serious business. Nobody wants a leak, environmental disaster, or regulatory fines. So when we talk about advanced risk assessment in pipelines, what's that exactly? What that really mean?
Yeah, no, that's a great question. So let's go to slide 13 if you could, Brad. So
Okay.
there's three pillars of this this webinar. One being PODS, the other being advanced risk assessment, and the other being machine learning. So I thought I'd put this together to kind of contrast and describe what we're talking about here. So what I'm showing you here is PODS in the center being the structured data source, and on the left-hand side you have a traditional approach to risk. And normally the way risk happens is there's deterministic rule sets that are set up and applied to structured data to get results. So we'll just call this traditional. There's a lot of different names that we could give to this thing, but that's kind of what it is. You're applying some known rules to data. Now, machine learning is kind of a subset of what we're defining as advanced risk assessment. Okay. And with machine learning, what you're doing is you're using the same exact data in PODS, but you're extracting out and learning the rules. Okay. So the rules are data driven, and these rules can be converted into these digital objects that can float around and be used in a lot of different places to be used for making predictions. And those predictions can be things that are relevant to we as risk engineers, things like probability of failure, consequence of failure, and overall risk. So that's kind of like the big picture and how I might distinguish advanced risk assessment, how machine learning fits in, and the current way of typically doing business with risk and how things are changing.
And those things are definitely changing, right? When IMP regulations first came out in early 2000s, we were still all on flip phones, and look at us now. The things definitely changed quite a bit.
Yeah, for sure. And we may want to take a look at the next slide, that 14, since we're talking about what's going on in the industry. So as some of you may know, a segment of U.S. operators are required to report what kind of risk approaches or methods that they're using. And this is kind of interesting. So I broke down the 3 years, can't read that very well, but there's 3 years of trending here of the types of approaches. And what you can see there on the top, the traditional trend line, the use of traditional kind of models like rule-based models are decreasing, whereas we're seeing advanced models increase. And these advanced models could be machine learned, probabilistic based, or fully quantitative. And what might be driving this, it really we think are two things. One would be PHMSA is kind of softly encouraging companies to go down the QRA road. So it's happening, like Rita said. So I think we're going to see things pop in here in the future that are going to drive this further. And probably the second bigger driver is the fact that you can use these data-driven machine learned algorithms now to monetize risk for the business people on the line here, the leadership. You can start to quantify risk, just like other industries do, the automobile industry, the insurance industry. They all know what their risk profiles are in dollars. And what this allows us to do with advanced techniques is to start monetizing, risk in dollars, so that can support, better, or called optimized resource allocation decision making.
Well, that sounds fantastic, Mike. But more specifically, Rita, I have a question for you. I know the PODS is a foundation for everything we talk about here, from risk assessment all the way to AI-powered machine learning, deep learning, prediction, everything else. Can you tell us a little bit what kind of PODS, what support PODS can provide, like different threats? We're talking about, the corrosion, third-party damage. Can you name a few so help us to understand PODS can help in there?
Sure. So PODS obviously is very helpful in to store your data and to organize your data. But again, data by itself, if it's not analyzed, if it's not integrated, doesn't really tell you anything. It's just data there. So if if you use the tools, like for example, here we have a Geonamic Pipeline Office Studio, which has a lot of great built-in capabilities to visualize your data, to do quick analysis, or to perform complex calculations, and obviously the risk modeler extension, the module, you can run the risk. So here on the screen we have example. Go back, please, Brad,
Okay.
to the previous slide. I'm just going to make a few points really quick. This is example of operator that it was trying to decide if it's cost effective for them to replace certain section of pipe. So all this area used to be agricultural land and undeveloped, and then in the last few decades, a lot of developments came in, shopping centers, and now you see where that green area is in the middle, a golf course and a resort that is happening nearby. So when they looked at their data, right in the middle of your screen, on the screen, you see the CP levels dropping a little bit. You have a lot of anomalies. You have on this top bar where you have those gray little marks. So those are all sleeves. So obviously something is affecting that stretch of pipe more than other sections, and the core reason being as it being agricultural land, there was a lot of fertilizer used in the soil conditions and degrading coating and things like that. So those are very practical examples how you can, even without running any calculations, you can bring in all your data. You can, format these bands to your liking and take a look at what's happening. And just by quick glance, you can see, okay, there's a problem in this section right there in the middle. So we should address it sooner rather than later, before you have to go in and dig up an expensive golf course or resort or something like that. So those are very helpful and practical applications.
That's great. Thank you for sharing those real world stories. So the PODS in this case is like a perfect fuel for AI, and tools like a risk modeler feeds some really clean data into machine learning models and to predict, if there's a pressure spikes, for example, quickly we can identify some problem areas. So that's bridged, our next topic, AI and machine learning. Mike, I'm gonna go start with you. AI is a buzzword. Everybody is throwing around here these days, but in pipelines, it's more than hype. It's saving pipelines and budgets. So Mike, let's clear the air here. For people just know a little bit about the topic, what's the difference between AI and machine learning, and how they are changing risk assessment these days?
Yeah, you bet. So maybe let's talk about the fundamentals then. That might help. And if we go to 16, I think that's what it is. Yeah, what might help here?
This
Yeah,
one?
right
Okay.
there. Yeah, right there. Okay. So sometimes AI machine learning, they're kind of like just melded together, but they really are two different kind of practices. Okay. And what I've tried to do here is to distinguish, the difference here. So very quickly, let's talk about this flow here, because everybody is probably using their favorite AI tools to do all kinds of things like right now. And I know this stuff is built into Esri too. But on the left-hand side, what you can see here is that AI is really good at predicting the next word in a sentence. Okay. And it's very good at writing code and things like that. And we use LLMs, or they use LLMs, at least right now, to support these predictions of the code and the next word in the sentence. As you move to the right, you'll see this thing called MCP, which stands for Model Context Protocol. And this is something that's emerging and becoming very important as a bridge between AI and machine learning. Because the big difference here is machine learning is generally working off of structured data, large structured data sets like PODS. And you can use AI now to write code that can then query, against the PODS data set to then give you predictive models like I showed you in a previous slide. But it's this MCP that's going to become strategic in allowing this to actually bridge and happen. So I guess in summary, I can't see everybody's faces and if they get this or not, if it's new, but AI is very good at working in a context window, a long set of instructions. whereas machine learning is really traditionally, and it's been around for a real long time, but traditionally mining large data sets to find patterns that can then be turned into predictive models. Okay, that makes sense?
Yeah, that makes sense. So AI and machine learning, machine learning is more like a workhorse under AI, and you even give us some real examples, in practice. That helps a lot. Let's just step back a little bit and zoom out. What is the state of AI and machine learning in U.S. pipeline risk assessment these days?
Well, if you go to that previous slide, I think that kind of shows the trend. What's going on is since the data has become more structured and available, and sometimes freely available, machine learning data-driven approaches are becoming more popular. I can tell you with the subset of people that we talk to, the interest is very, very high, and they all have some kind of initiative around machine learning and AI. Okay, and many times it's to augment their current traditional processes. So that's kind of what we see. I mean, I'm just one opinion. I just see one subset, but that this also shows you, this graph here shows you that that's a general trend too for those that are reporting their methods.
It's great. Thank you for explanation there. So why bother? Why bother with the machine learning? What's the payoff? What we're getting?
Yeah. So maybe I'll give you more of a real example here. Something that we worked on, a project that turned out to be pretty well. If those of you are familiar with inline inspections, and especially like EMAT surveys, it can cost like $1 million to run an EMAT survey for the purposes of finding cracks on a system. And the question becomes, well, should I run the tool or not? When should I run it, or not? Now, in addition, for those that might be familiar with EMATs, historically, and this is kind of like just what we see, is these surveys tend to over-report. So they tend to tell you that you've got problems in places where you don't necessarily have problems. So this particular project, what we did is we used historical EMAT observations and actual physical digs, and we learned a prediction model for predicting where cracks could be driven, and we utilize these $1 million surveys or substantiate why they shouldn't even be run in the first place. And then maybe more importantly is to start to sift through all of these false positives, because to do a dig could cost you, 100,000, 250, a lot of money. Yeah. So this is just an approach to make the process more efficient. Okay. And having one little point, having the data in a structured format, the ILI observations, the repairs, and all the other important data that's important to the model, besides the inline inspection results, is critical, to a fast and successful low-cost project.
Yeah, that's good to know. But I have to ask you, Mike, this question. I mean, this always bothers me. When you predict something based on AI learning and everything else, you have a result. So you have a prediction, right? So you have your low risk, your high risk areas. What if the results actually disagrees with the engineer's judgment? Who's going to override who?
Okay. Well, the gold standard for machine learning is always to test your model against data that's independent, that has never been seen by the model. Okay. So the process and the data.
80-20% rules.
Yeah, 80-20
to train your model, 20% to validate.
Right. But the important point is independence. Okay. So you're not leaking existing knowledge into your training data. So that's one way. And then the other is just many times when we do this work, we take both result sets and we line them up together. And it just becomes information to make decisions. Okay. We're not saying that, hey, the deterministic way needs to go by the wayside, or the old ways need to go by the wayside. There could be a lot of value in that. We're saying, hey, augment currently what you're doing with the current data. So this is not a big lift to go get a whole bunch more data, because it should be there in PODS. It's like learn the patterns, see if they agree or not with the traditional approach, and then just work from there.
Right. And probably it's important to understand the difference between correlation and causation, right? And not to confuse those in in the data. Mike, don't you think like there's sometimes a challenge to separating the things and saying like, okay, is the zip code causing more third-party damage?
Right.
Like you can
Yeah.
integrate all kinds of data and have like very good insights that are not really
Yep.
useful. Or
Yep.
so there would be not good insights, right?
Yep.
That's a great point. And also, just one more thing for both Rita and Mike. We've been doing this for long enough. We know we focus on high risk areas, different segments, stuff like that. And then we go out and mitigate, right? Repair or dig or replace. So we kind of focus on the high risk segments for the most part. But for those low risk segments, that's where I was a little concerned about, because typically that based on that results, we will not do anything. Not anything. We will not do a lot of things to even worry about those. Do we have any real life scenario, Rita? Maybe that's a question for you. Actually, something happened in the low risk area?
Well, anything can happen anywhere, no matter how perfect your model is, how perfect your prediction is. There's always one off that we cannot predict, right? It just if you go and get your blood work done and they give you a rating of how close you are to the heart attack, you can live another 50 years and nothing will happen to you. You could drop dead tomorrow. So similarly, I think even if you a low risk, things still can happen, whether maybe your assumptions were wrong and you did not know something that you did not know, or maybe it just purely an accident. I have an example of an operator a few years ago. They had a small leak in a highly sensitive area. It wasn't a lot of environmental damage, but still, a lot of visibility and a lot of questions were asked. How did we have that leak? We run ILI every 3 years. We have the risk model. We have that. Engineers analyzing the data. How did that happen? And when we look back at the data, the joint was clean. There was absolutely nothing that would have triggered any kind of action, any kind of high risk score or anything like that. But what they didn't have is depth of cover study, and turns out to be that area was very, very shallow with a lot of bike traffic. That degraded soil, and I think they were also mentioning that people were riding ATVs in this area and just spinning wheelies and all kinds of things happening that degraded the coating, and it develops a pinhole leak that was not detectable by ILI. So yeah, even in low risk areas, things do happen. So it's important to integrate the data and look at question your unknowns, especially.
Yeah, that's great to hear. And also, the most important thing for me personally is you got to be able to explain what you're doing. You produce traditional risk results or machine learning results. So Mike, this may be a question for you. For non-ML stakeholders, especially when AI results contradict to traditional risk, what kind of exercise you can do to explain and make sure they understand the results?
I think we have a poll scheduled to see how people are using risk results. I'm very curious before you start, Mike, of are people really using risk results? If they have some model that generates a score, 4,897 points, what does that score mean? How do you apply it? Is that a good score, bad score? So I'm curious to see how people are using the risk results.
Yeah, hopefully we get some answers from the audience.
And maybe while we're going through the poll, let me, if I could, follow up on a point that Rita made here. And it's an important fundamental distinction, which is if you look at traditional ways of risk scores, I'm not saying everybody does it this way, but the scores are often not characterized with any level of uncertainty. Okay, so this gets to the heart of your question, Wong, about low risk segments maybe having a problem. Is that with machine learning is statistically based. It's distributions and things like that. So any of the outputs that come out of machine learning are going to say, hey, the probability of an event here is, let's say it's 71%, plus or minus 20%. explained through an R² of 90%. Now, we don't have time probably to get into what those metrics mean, but those become critical in looking at your results. Because if you have a wide uncertainty, and although the risk looks like it's low, those tails of the uncertainty could reach into the higher risk areas. Like Rita said, it's never non-zero, okay? So that's just a fundamental thing. Everybody should brush up on their statistics. Even old people like me, were able to learn that stuff. Now I could go into an example too, so we can hold off, but I do want to follow up on that. The example of the explainability, if you will. If you want to go to that, we can go to that.
Yeah, I mean, yeah, we can have this discussion, for a whole day. I 100% agree with you. Nobody can predict 100% accuracy. Even, everything points to a leak in 5 years. It may still not happen, when the time comes. It's a science of a probability. We can say, leak can occur within 80% confidence or probability, either based on actual growth rate calculation with the real ILI data or a prediction made by AI, right? But again, it's even you have 80% meta loss today. The same anomaly was 60% 5 years ago, for example. That's a 20% increase in 5 years, which translates to what, 4% per year. So you will say, okay, I have a confidence in 5 years later, it will reach to 100%. That's a pure mathematical calculation. Everyone agrees. But I have to tell you, it could be completely incorrect because we made a lot of assumptions. We assume it's a linear growth, right? So in 5 years. Secondly, we didn't have all other considerations in the calculation, weather, new construction, soil type change, you name it. So
right.
100% will not happen, probably.
And we know how
years.
that weather works, right? And weather forecasts, it says 5% chance of rain. I think you should always be packing that umbrella in the back of your cars.
So let me comment on this if I could, is that there are machine learning techniques that allow you to manage the temporal aspects. These have been around for a long time. It's called time series analysis. So rather than do a snapshot, like looking at a growth rate and doing some linear kinds of calculations, no, look at your temporal data and see how that feeds into your prediction model. So think about it. Feed in your CP data, feed in your seasonal weather changes, feed in the construction practices, how they've changed over time. Things like that all become part of your predictive model. And if that stuff's available in PODS, you can see it's an easy reach now, to do time series type predictions for time dependent kind of threats is what you're talking about.
Yeah, the live risk data we were talking about, right? The new features that Esri and Geonamic software can enable, those time sliders, where if you have your PODS data set up and implemented that it's compatible, with Esri's vision of how to use that temporal data, you can do a lot of different analysis, and then you can account for those changing conditions, right? Because things are not linear. So if you had maybe a susceptible segment because of previous CP history and soil conditions, and now you replace the coding, you upgraded your CP system. So those things would not follow the same trajectory, your prediction. So you have to constantly reevaluate them using, your current data, and then be able to compare it to historical trends to see if you see any patterns.
Good. We are kind of short on time. We still have a lot of things to cover. Let's bring everything together. So we've got PODS as a foundation. We have AI as a brain. We have our geonamic risk modeler as an engine. So Rita, I'll start with you. How you envision everything, all these pieces come together in practice?
Well, I'm a very visual person, so that's where I would start. Just not, when you look at something in the spreadsheet, it's a very different picture than when you look at something on a map or a dashboard or the banded alignment sheet. And it allows you for better data integration. It allows you to bring elements together that maybe you didn't think they were connected, but then you start seeing different patterns emerge. So I think that's important aspect of in the future of GIS and the risk management and pipeline integrity, that you can start making those decisions based on data integration. It's a very important topic. Obviously, PHMSA is always stressing out data integrations and interactive threats, right? So people not just looking at their little things in silos like SMEs that are in charge of corrosion. They just look at their CP data, and the ILI analysts, they just look at the pipe tallies all day long, and then maybe the right-of-way and legal people just deal with landowners. But when you bring all these data sets together, you can have some eye openers for sure.
Mike, do you have any comments?
I do. Do we have time for a 2-minute story for
Yes,
slide 18
absolutely.
through 22? Let's fire
Sure.
that
Love
thing
to
up.
hear some
Yeah,
real stories.
yeah, because I'm kind of visual too. But if you take a look, yeah, Brad.
I mean, yeah, working on it here.
Okay.
That's the corrosion risk example.
Yep, it's the map
Okay.
first. Yeah, yeah.
There you go.
Okay, so how does this all work together and integrate together? Well, here's just a picture of a pipeline in Texas with a lot of stuff going on around it. And those red dots are corrosion observations that we want to learn from. So we go to the next slide. And what you'll see here is PODS can be the repository of all the relevant data for, let's say, corrosion, because that's our interest in making a prediction. We just apply a machine learning process to that data to find patterns that could become predictive models if they perform well. Now you go to the next slide. And if we want to open up the models box and take a look at it, everybody's probably heard of weights, especially in the AI world. Well, with machine learning, there's weights too. Now, what do these weights tell us? That we have a learned model, we're opening up, we want to see what's inside there. And what this is showing us is the relative importance of the different pieces of data to the target of interest, in this case, external corrosion. So this becomes useful in quality assurance and planning your data processes and things like that. We can go to the next slide. Now, once you have a model, it performs well, then the practical application is applying it to pipelines. This is just showing a box plot, results showing you corrosion rate predictions or probability predictions in a box plot format by pipeline. So this allows you to sort, prioritize, and identify outliers too, that although that pipeline could be characterized as low risk, it might be high risk in certain parts, and you might want to know that. Next slide would be explanation. Okay, this is a big topic in the machine learning world. We're bringing us into the pipeline world, but many times you want to know, well, what makes up that prediction? Why is it high? Why is it low? What are its principal components? And that's what this shows you right here. There are certain techniques like Shapley and Lime, breakdown plots, and others that will allow you to walk the pipeline joint by joint and be able to see exactly what's driving the predictions higher or lower. And clicking on any of those bars there is traceable all the way back to PODS. So you can see, well, what's the source data? What's going on here? Okay. And then the last would be, we touched on this a little bit. Is that S-curve, Brad? The next one? Yeah. So, and I'm covering this a little quick here, but those mechanical engineers probably know that, this is a survivability curve. This is a 2-parameter Weibull curve. And this is something that you can learn with machine learning. Okay. If you've got the data, if you have the temporal data, like the defects and how they've been behaving over time, you can then learn a model that can predict probability over time. Very similar to a Monte Carlo analysis too, but that's all we're getting out of here is if you know the age of the pipe in this case, you can make a prediction of what its probability is for external corrosion, given all the other conditions around the pipeline, the soil, CP, etc. So that's a little story that kind of shows you how the whole thing integrates together with PODS, with machine learning, with AI writing the code, and of course the Geonamic tool.
Yeah, and so making your data and your system to be time aware, that's very important, right, Mike? I think it's, Brad, would you say it's a pretty new feature? Are people taking advantage of that time slider and data being time aware? I know you have to put in some effort and you have to
Yep.
begin and end dates for all your events so things make sense. So I think people
It's been around, a few years in the Esri platform, but really starting to kind of get some traction in the pipeline industry right now. And it's something we see particularly, as folks move to the new data models, it's a priority for them, to take advantage of that kind of out of the box functionality. So
I'm looking forward of how people will utilize that, as they migrate to Pod 7 and then reset their base timelines for all the events that they loaded. If they keep up with it and keep retiring and replacing events and honoring the pod schema and not just I think it wasn't managed like that before. People would just keep all their deleted routes, all their retired routes, and then everything would get confusing and you have to filter things out. So this time awareness, I think that's going to be a very powerful tool in the future.
Good. You guys are over 2 minutes, Mike. But let's continue here. Yeah. Well, that's great. That's a great discussion.
Cut me off whenever you need.
Let me do something real quick. If you guys can see, I want to talk about the PipelineOffice real quick here. We all know PipelineOffice is the beast of a platform with all the different features. I think it's over 250 features just for the desktop version. Plus the modules like a risk modeler, integrity analyst, you name it. So it's not an easy task for a casual user to command all the different functionalities and features. So by leveraging AI, we can simply simplify the navigation, provide some tailored guidance, stuff like that. For example, as you can see here on my screen, I can ask, how to generate, dig sheet, and then I'll get a answer from my AI-driven dialogue here, and just show you how you can step by step do things like that, or how to run compare, how to do anomaly matching, for example. Just a really quick. Ask some questions to get back to me, and then I can even say, okay, I will do one more thing real quick here. I'm gonna ask my AI-driven alignment, produce alignment sheet, open alignment view for route. I'll just paste that in here. So automatically it will open up alignment view for me. As you can see here, automatically detect that route and open up alignment view. And then I can go here and say, okay, add the valve. So it's just, so that will automatically add a valve here. And then I can even say, okay, add a sleeve, casing, and T, right? So I can do that as well. So, and then it will automatic. So basically, this will AI-driven automation tool will allow us to open up PipelineOffice Studio platform to future developers, to automatically generate all those symbols, complete some complex task. Just imagine, I come to the office, check my email, and download the ILI pipe tally, and drag and drop into the PipelineOffice platform. AI will analyze and tell me, okay, this is a MFL run for pipeline ABC and performed on this date. What you want me to do? I can preview the alignment, load and align an ILI, compare to, for example, 3 historical ILI runs in a system, do some anomaly matching, even predict where the problem areas will be based on, the current ILI file. So that's where we're heading to.
Can I be the beta tester, please? That is an awesome function, and I want to test it out. It looks like it could be a time saver, not just for users that are familiar with our platform, but anybody just starting new, instead of going back to the user guide and trying to read of like, how do I do it? I think they showed us during the demo or training but to be able to just type in and get the instant result, that's awesome, Wong, Brad.
It looks
Thanks.
simple enough to where I could even use it, guys. I'm super stoked. Like I can type, right? I
Well,
can do
well,
that.
we have a plan. We are aiming to maybe roll this out in the next 6 months. So before next pods in April, I think we're gonna have something to show. So it's like a pipeline office, 24/7 to monitor your system, forecast and possible failures, predict some corrosion growth, where it needs to be digged or any possibilities we can do to mitigate the problem. So we ran out of time, but let's talk a little bit further from here. Mike, I want to go from you. We talk about the pods, we talk about the AI. Um, Tell us a little bit the benefit, payoffs, what we can do to accomplish here.
Yeah, I think I described that in a couple examples. One
Mhm.
thing I did want to hit on before we close is it's kind of like a final thought thing, if you wouldn't mind, just so I don't forget that there's a lot of anxiety around AI and machine learning right now, especially with regards to replacing human work. But I wanted to say that we take a different kind of like more optimistic view of this, which is, there's going to be significant disruption, in the way we do our work. But you just got to learn the processes and how this stuff works. But I think what it's going to do is it's going to have us work on more valuable edge cases that AI, machine learning, is not very good at. So it's going to be about directing us to working towards the more important things. And I think it's going to be a great opportunity, for all of us in the future. There's going to be plenty of stuff to take care of. So I just wanted to highlight that, Wong, before as it may be the last thing I say here, but
No, that's not the last thing, but I do have a follow-up question. What kind of saving? I mean, can you quantify that to a dollar amount, maybe for the operators,
yeah.
executives, what
Okay.
kind of a saving they can accomplish,
Okay.
yeah.
We could go to a slide and I could show you that, or I could just talk it through.
Yeah.
Yep,
Okay.
trying to find it for you. There we go.
Yeah, it's the double. Okay, so here's something that's kind of real. Okay, well, it is real. And what this is showing you on the left-hand side is a histogram of risk scores based on a traditional scoring model. And then what's overlaid on here are where corrosion was actually found. So this is kind of like validating an existing traditional model. And it's showing that, well, the current model is able to find 61% of the actual corrosion. On the right-hand side, all we did was learn a machine learned model based on the same exact data on the left to come up with a different predictive model, and it happens to predict corrosion 20% better. And in absolute terms, that's 33% better. So what this means from a real standpoint is by improving the predictive accuracy, now you're improving the ability to weed out the false positives and to find things that really matter. And I think over the years, you're going to see some more use cases that are going to be published that are going to talk about actual real savings, based on this data-driven machine learn approach in reducing incidents and reducing the maintenance costs for going out and looking for something that's not really there.
Okay. Yeah, that's great. That's great to hear, Mike. Before I let you go, you're the pioneer in this, field in the machine learning in the pipeline specifically. Where do you see? What's your envision? Machine learning, AI, ML in the risk assessment in 5 to 10 years.
Oh my gosh, if I knew
Yeah.
that, I wouldn't be doing this. Um, all I can tell you is it's going to change, and it's very, very hard to predict where it's all going to go. We all know that's just going to change, and I would just recommend, learning what it's all about, learning the fundamentals, the first principles of what machine learning is really doing. But that's probably the only thing that I could say is, the prediction is uncertain, where it's all heading.
Now you sound like a weatherman, Mike. Like, oh, we predict the rain, but don't hold me to it. It might rain, it might rain not.
Yeah.
But everything is moving faster, right? Like with any technology, if you think about, when the pipelines became mainstream in the 30s and 40s, and some of these lines still run today, things changed very slowly for a very long period of time, probably till like late 90s, when GIS and all these other different technologies were invented that enabled people to look at their data differently. So I think it's very, very important to get your data, to get a hold of your data first and put it in a structured platform to get it out of people's brains and memories, especially as the older workforce retires. And the guy that laid this particular pipe, and he watched somebody to put coding, so he can tell you exactly what kind of coding they used. He doesn't care what's in your database. He's like, hey, I was there, I saw it was coal tar, so whatever your database says, don't believe it. So if you capture that knowledge now, and it will make all your future predictions much better, and also get out all your data out of paper forms and disconnected Excel spreadsheets and PDFs. You cannot analyze that data. I don't know, maybe you can feed a whole bunch of PDFs to AI and they can extract something from it, but it's much better if you have a database, for sure.
Yeah, I can see
Right,
AI
Monique?
will be big on AI will be big on, especially if, filling those data gaps, like missing data, identify some gaps so that's where actually PODS will come in. Maybe I can ask Monique, we talk about this risk and PODS, maybe can you tell us, like small operators can afford PODS moving forward? I know these days cloud-based PODS may be, a possibility. Monique?
Absolutely. The board is really looking forward to a lot of new things, including AI. And a lot of that has to do with Mike and Rita's and Wong, your great panel from the last fall forum that we had, right? And so we know now that this is something that we have to do. If you look at the results of the poll, the majority of people on here are modernizing their current risk management approach or model, right? So this is all great news, right? Everybody's getting their data in order. Everything's great. We know, unfortunately, from NTSB, at every single incident or accident that happened since Bellingham, Washington, had to do with missing data, misappropriated data, data not available to the right people at the right time. So, we know that this is paramount for us moving forward, and what our conversation is about. So, Wong, if you don't mind, that's going to lead me into, the conversation we're going to have in the fall, which is, I do have to say, connected to Brad and Geonamic for sure, are what we're going to be talking about a lot is, what we're moving towards in the future, right? That our two core models on Pod 7, APR and utility network, and then we're bringing all these modules to bear as well. So the next slide will show you all the different modules that we have, and we're working with Esri to get those. Oh, maybe I missed that one. Sorry. We're working with Esri to get those on a UPDM as well. So a lot of cool stuff. Now, here's the one thing that I think that risk people like more than ever, and you can never have too much of, which is data, right? You guys love it. You want all the data, right? Give me all the data, because I think the more data, right, you have, the better your analysis is going to be, the more you can put forward on that and use that analysis for other things. So that's what we're going to be talking about in the fall. We have our keynote speaker for the fall forum is going to be Danica Yeager, who actually used to work for Brad and got her start in GIS, and she loves maps, and now she's the SVP of natural gas for TC Energy. So believe it or not, that GIS degree can get you some places, guys. And then as a follow-up to the panel that Mike led last fall, right, we're having another conversation around geohazards, right? Because it's just as important to know what's around your pipeline as what's in your pipeline, as well as information sharing, right? So how do we get the industry to a place where we can have maybe even an industry-wide database, right? And how do we use all of that data to learn, right? Because that's about the digital twin. So these are a bunch of updates we have coming up. I do want to mention to everybody as well that PODS will be out at the PHMSA event on the 18th and 19th. There's a public meeting here in Houston to talk about what data PHMSA is going to require and get some feedback from operators and the public. So you guys please try to join that as well so you can be part of the conversation. So yeah, October the 21st, come to the forum. You're going to see all of these beautiful people that are on your screen right now and be able to ask them some follow-up questions as well. So Wong, did I answer your question?
No, so my conclusion is PODS is the future.
I love it. Oh my God, can we make t-shirts out of that?
Wow.
And my conclusion is if you have questions about all this stuff, call 1-800-Geonamic. No, I mean, I'm so grateful to you guys that you came and shared this knowledge with everybody, and that you were able to join us here to talk about this very important stuff, right? I know pipeline companies are all about trust but verify, but you guys are really pushing the ball and moving a ball forward in where we need to be. So I congratulate all of you for your efforts in pipeline safety in the digital twin.
Thank you.
Thank you.
Thank you.
Awesome.
Great.
And with that, we'll sign off to everybody. Thank you so much, Brad. Thank you, Mike. Thank you, Rita. Thank you, Wong. And thank you to everybody that participated and showed up today. We will have this available on our YouTube channel as well as on our website. So stay tuned for more from us. And you guys have a great day. Thank you.
Thanks, everybody.
Thank you.
Bye.
Thank you.